So let's finish up with geometric sequences and series. I'm going to zoom in a little bit and show you what I wrote down. I just want to remind you, I kind of didn't line it up, the difference between explicit and recursive, and the difference between a sequence versus a series. Remember, a series means plus, 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 and a sequence is just a list of numbers. Be aware of that for the quiz, okay? So we're going to create an explicit and a recursive equation. So the first thing we do is we find the pattern. So the pattern is times 3 times 3. And then remember the formula is a sub n equals a1 to the r to the n minus 1. So what's the first term? 5. What's the ratio? 3 to the n minus 1. Okay, that is the explicit sequence. If I was to do the recursive sequence, a sub n equals, well, what are you doing to each number to get the next number? You're taking that previous number and you're multiplying it by 3. But what do you have to make sure you do? You have to make sure you state a number to start with so I know how to continue. Okay? I also want to remind you, let me get a piece of paper, that if I wanted to create an exponential equation, instead of doing a sub 1 r to the n minus 1, it's a sub 0 r to the n, which means I would find the 0 term. If this is the first term, this is the 0 term. If this was times 3, then the other way is divided by 3. 5 divided by 3 is 5/3, and the ratio is 3 to the n. Okay? If I wanted to, I could write it that way as well. Okay. All right, let's go to the next one. I look here, the next pattern is divide by 2, but we know we don't do division, so it's actually times 1/2, times 1/2. And you'll notice I always write the pattern twice. Why do I write the pattern twice? To show it's something that happens again and again. A pattern isn't something that happens one time. A pattern is something that you're like, oh, hey, that happened again. Oh, uh-oh, it happened again. Or, that's great, it happened again. A sub n equals a1 r to the n minus 1. The first term. This should be something that's no problem at this point. And then 1/2 to the n minus 1. Do me a favor, write it as exponential. If you're writing it as exponential, y equals, if this is the first term, this is the 0 term. So instead of dividing by 2, I multiply by 2. 1/2 to the n. Now let's make the recursive. Well, recursive means I need the previous guy to get the next guy. How do I get the next one? Oh, I multiply by 1/2. If I want to mess with you a little bit, I could say, I don't want the first term. I'm going to list the second term, and that's 160. Recursive, explicit. Okay. It gets a little bit more intimidating here, but you can handle it. I notice that it is dividing by 3, but this is positive, so it's dividing by -3, which is really multiplying by -1/3. And if you don't believe me, 2 times 1 is 2, 3 times 3 is 9. If all I had were the fractions, and let's say the 2 and the 6 weren't there, I could go parentheses, let's turn this on, 2/9 divided by 2/3, and then I second PRB it, and I can see that the ratio is 1/3. So I can use my calculator to help me. All right, a sub n equals a sub 1 times r to the n minus 1, where r is the ratio, r is the pattern. X, what is the recursive? And hopefully you're just doing this yourself at this point. -1/3, a to the n minus 1, a1 equals -6. Okay, recursive explicit. Okay. Now some of you go, well, this one seems difficult. Well, what I like about this is 1. So I know 1 times any number is itself. So the pattern is times 1.5. Okay. And some of you go, well, shouldn't you change it to 3/2? Normally I would, but since they're all decimals, I'm going to respect the decimal. So a sub n equals 1, which means I don't need to write the 1. 1.5 to the n minus 1. Recursive, a sub n equals 1.5 a to the n minus 1. The first term is 1. Okay? This should be second nature by now. This should be second nature. All right, decide if each Sequence is arithmetic or geometric, or it's neither. So arithmetic means an adding and subtracting pattern, a difference. Geometric means a multiply, divide, but divide is really multiply pattern, ratio. Then determine the equation. Okay? So hopefully you're going to see it faster than me. Plus 11, plus 11. So that means it is arithmetic. A1 equals A1 plus n minus 1 times d. The first term. Distribute. Equation. 11n minus 29. Now remember, another way I could have done this is if this is plus 11, I could have gone minus 11 to get the 0 term. That's my blue, that's my pink, that's my pattern in my start. So this is arithmetic. I'll just put a name for that. And the next one, this one doesn't seem as obvious, okay? Well, I noticed that this is times 2, and this is times 3, and this is times 4, and this is times 5. So is that arithmetic or geometric? No, it is not arithmetic or geometric because it has to be the same number that's consistently going. There is a pattern, but it would be considered neither. Okay? And if I had more time, I'd figure out the equation. But to be honest, to figure out this equation, it's kind of some guess and check. I think it's going to be quadratic. It feels quadratic, but I'm not 100% sure. Okay. All right, so now let's look at this one. This one looks like it is divide by 4, but we don't do divide, so multiply by 1/2, which means it's geometric. A sub n equals a sub 1, 1/2 to the n minus 1. I didn't write that very pretty, but you get it. I could have also written it like this, where instead of finding the first term, I find the 0 term. So instead of dividing by 4, I multiply by 4. 1, 2, 3. And then 1/2 to the n. I like this one better, but I actually like them both. There isn't a better or worse. Okay. Just stay consistent. All right, so give me a second to read these, and then we will go over it. One sec. So she already has $300. That means what we're starting with. Okay. And the savings account promised to double her money at the end of each year. Okay. So what does double mean? Double means times 2. Oh, if it's times 2, then boom, I know it is geometric. Okay, because it's a multiply pattern, which means it's a sub n equals a1 r to the n minus 1, or a n equals a sub 0 r to the n. Okay. I actually like this one better because that's how much she started with. And to me, that seems more realistic for me to do. So I'd go 300 times 2 to the x, and that would be the equation. But if I'm doing it as a sequence, it's a sub n equals 300 times 2 to the n. Okay? They want to know how much money she's going to have after 6 years. So I put 6 in there. 300, 2 to the 6th. So 64, one sec, is 192,000. Did I do that right? Okay. I think I did that right. Yep. All right. So that's how much money she would have if she doubled it. And some of you go, wait, that doesn't make sense to me. Okay. Let's say you start off in year 0 at 300. If you double your money, you now have 600. And you double your money, 1,200. Double your money. Double your money. Yeah, something seems off here. Double your money. Double your money. I think I added an extra 0 somewhere. Hold on, let me... Oh! I put 3,000. That's why. Okay, and that should be 192. Now that makes more sense. Okay. So, 19,000. I knew something seemed off, but I wasn't 100% sure. So now they want to know how long will it take her to save for a $2,000 car. So this time what they want you to do is take the 2,000, and it doesn't go in for n, it goes in for a sub n. So that way I'm going to go here. 1, 2, 3 equals 300 times 2 to the x. So what would I do? I divide by 300. by, which is 20 over 3 equals 2 to the x. Does anybody remember what to do? Log both sides. And this is really log of 20 over 3 equals x log 2. So now I'm going to divide by log 2. And I'm going to pick up my calculator, parentheses, let's see. Oops. And it tells me 2.73 years. So it's going to take, now nobody talks in 2.73 years, and you can't have part of a year, so we're going to say about 3 years. And we did this, I don't know if you remember this, when we did logs back in quarter 1, or quarter 2, depending on which video you're watching. Okay. Let's see, this one, Tyler's saving for a video game. He already has $28 that he got from his grandma. And mother told him if he put away the dishes after dinner, he would receive $3 for each day that he did it. So that means that's going to be happening again and again and again. So that means he's going to be getting plus $3, plus $3. Ah, that's an arithmetic pattern. Okay. So if I was doing a linear equation, it would be y equals 3x plus 28. If I was doing it as an arithmetic sequence, I would go an equals the first time it happens. So that would be 31, because this is the 0 time. If he hasn't done any dishes, then he's not going to get the money. Plus n minus 1 times 3, 31, plus 3n minus 3. And then 28 plus 3n equals a sub n, so I got the same thing. A lot of you are seeing this way is probably just easier. Okay, it says how much money would he have after 1 week? So what do you guys think? Think I should put in 1? No, because this is talking about weeks, but this is talking about days, which means I should actually be putting the number 7 in here. 3 times 7 plus 28, 21 plus 28. 49. So he's going to have $49 after a week. This time it says he wants a video game that's $80. So this time, instead of putting 80 in for X, I'm going to put 80 in for Y. And let's be honest, this is real life. This is what you're going to be doing when you're trying to figure out, okay, how long is it going to take me to earn something? And then X equals 114 point whatever, so about 15 days. Okay. All right, we need to decide if something is a sequence. Let me see how much time I have. Okay, I need to decide if it's a sequence or a series. Remember the difference. The series means you're going to be adding things to find the sum, to find the total. A sequence is just, okay, the list of the numbers. Like I want to know after the 5th day, what's it going to be? All right, so let me see. They build a nest, as shown to the right, as the patterns form. So it has, the first ring has 6. The second has 12. The next one has 18. If a colony of hornets builds 10 rings, how many cells will they have in all 10 rings? Oh, they wanted all 10 of them. Not just the 10th ring, that would be a sequence. But they want to know in all of them. So I would have to go this, plus this, plus this, plus this, plus this. So that would be, let me move that up, I'm sorry. That would be a series. So let me say it again because you didn't get to see it. They want to know in all of them, so I have to go this one plus this one plus this one. Because if you think about it, if you're building a nest, it gets bigger and bigger and bigger and bigger, and they want to know how much is that. I know that's not a nest, but that's the best I could do. Let's see. So they say that the math club grows by $55 each month, which means it's going to go plus 55. That means that's arithmetic. The balance at the end of the first month, so at the end is 190. At the end of the year, produces a report showing the balance at the end of each month. What is the balance at the end of the 8th month? So they don't want to know the balance for, actually they do. They want to know the balance at the end of the 8th month. That means you have to go the first month, plus the second month, plus the 3rd month, plus the 4th month, plus the 5th. So that is a series. Let's see, he increases 25 cents.